2013 Civil Engineering Question 44. Elevation and temperature data for a place are tabulated below. So for an elevation of 4 meter, the temperature is mentioned as 21.25 degrees Celsius, and for an elevation of 444 meters, the temperature is given as 15.7 degrees Celsius. Based on the above data, the lapse rate can be referred as. The four options given are A. Superadiabatic, B. Neutral, C. Subadiabatic, and D. Inversion. The relevant NPTEL reference has been mentioned. So if we talk about the temperature profile of atmosphere, it is generally that when we go up, that is the elevation increases, the temperature decreases. So this is checked by calculating the derivative of temperature with respect to the elevation. This is referred to as the environmental lapse rate, and this is compared with the standard rate of temperature, that is called as adiabatic lapse rate, which is 9.8 degrees Celsius of temperature per kilometer height. So the first situation that exists is that environmental lapse rate is greater than the adiabatic lapse rate. This is called as a superadiabatic atmospheric condition. The second situation that exists is that the environmental lapse rate is less than the adiabatic lapse rate. This is called as a subadiabatic situation. And the third situation is when both are equal, and that is a neutral atmospheric condition. So given the temperature profile of the atmosphere, we can compute the environmental lapse rate and then compare it with ALR to judge about the type of atmospheric condition. So in this case we have been given with the temperature profile, so we will calculate the environmental lapse rate, which will be dt over dz. So we will take the higher temperature first, 21.25 minus 15.7, and we will again take the higher elevation first, that is 444 minus 4. So this would turn out to be 5.55 divided by 440, which would be 0.0126 degrees Celsius per meter, but we usually find ELR in degrees Celsius per kilometer. So we would operate 0.0126 with 10 cube, which would come out to be 12.6 degrees Celsius per kilometer. As we saw in the previous slide, the ALR is given as 9.8 degrees Celsius per kilometer. Here we can see that the value of ELR obtained is greater than the ALR. So this indicates that the atmospheric profile is superadiabatic in nature. So based on the above data, the lapse rate can be referred as superadiabatic, which is option A. The relevant NPTEL reference has been listed.